imaginary numbers, right? Until today, all of the numbers that you've dealt with have been part of the real numbers. And if you remember in the very beginning of the year when we did, the classifications of the numbers, it was like, okay, is this number real? And they were all real, right? It was always like real and then rational, integer, blah, 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 or real and irrational. They were all real. Now, for the first time, we're going to talk about numbers that are not real, and we call those numbers imaginary numbers, okay? The real numbers are basically all of the numbers that if you drew a number line, you can, plot them on a number line. So any real number can be plotted somewhere on a number line, okay? But we also have numbers that become solutions of quadratic equations that don't have real roots, okay? So where do we use this imaginary number that we talk about? Well, okay, so if you see here these circuits that make these lights, if you've ever worked with circuits, you know that in any circuit you have resistors and all that stuff, right? Resistors are measured in imaginary numbers, actually, okay? Okay, so what is all of this that we're talking about? The imaginary number is given an italicized lowercase I. So it can never be uppercase. It's always italicized lowercase I. We normally write it like that. Do you see that? It's just like a lowercase I. Okay? Now, I, the imaginary number, is the square root of -1. Okay? So take a look at this number. Here, 5i, -2/3i, I root 3. These are all purely imaginary numbers. Okay? You can have them in connection with real numbers as well. Then we call them something else, complex numbers, which we will get to. Okay, so where does this come about? Until now, we knew that we could have the square root of 9, and that would be what? 3. But we always said, oh, you can't have the square root of a negative number, right? But you can. Okay? So the square root of -9, and you don't have to do this every single time. I'm just going to do it this one time to show you. The square root of -9, this is actually -1 times 9, correct? -9. So it's actually the square root of -1 times the square root of 9. So the square root of -1 is I. The square root of 9 is 3. But convention is we always write the number first, then the I, so 3i. Okay? That's where it comes from. Are you going to do all this every single time? Please no. Okay? If you look at a number like this, it's the square root of 64. Square root of -64. Root 64 is 8, but there is a negative inside which comes out as an I basically. So it's 8i. Okay? Now, so the square root of -18. So if I have root 18, right, and I do like the factor tree, that would be 3 root 2, right? Yeah? But since there is a negative in here, it would be 3i root 2. So the I always comes after the real number. But if you have a number and a root, it's sandwiched in between the number and the root. It's convention, okay? So -125. The square root of 125 is 5 root 5. Because it's 5 times 5 times 5. So it's 5 root 5. So what would this be? 5i root 5. Okay. So remember here I said I is the square root of -1. So if you square I, you square root -1, which gives you -1. Yeah? So look at this table here. I to the 1 is I. I squared is -1. This is something that you just have to know as well as you know your name. So if you're walking down the street and somebody happens to tap you on the shoulder and say, hey, what's I squared? -1. That's how quick it has to be. So what's I squared? -1. Okay. I cubed is actually, huh? So I cubed is I times I squared, yes? So that's, I squared is -1 times I, how much is that? -I. Okay? Now, I to the 4 is I squared times I squared. I squared is -1 times -1, +1. Okay? So we went from I to the 1 is I, then -1, then -I, then 1. Now, I to the 5th is I times I to the 4. And what was I to the 4? 1. So that's just I. Okay? This is I squared times I to the 4. I know you can split it in different ways, but we're just going to, since for I to the 4 we got 1, let's just use that. So this is -1 times 1, -1. I to the 7 is I cubed times I to the 4. So it's just what? I cubed is -I times 1, -I. Right? Do you see how I cubed here was -I? Times I to the 4 is 1. Okay? So always split it. Since I to the 4 is 1, that's easy to work with. So this one we're going to do I to the 4 times I to the 4 is 1. Okay, look, we got back to 1. So look at how it repeats. I, -1, -I, 1. I, -1, -I, 1. Okay, so I to the 9 is I times, now we're going to split it with the 8. I times I to the 8. Because it's better, since once you lock in a 1, always use that because it's easier to multiply by 1. So this is going to be just I. Hang on, let me take your question later. I to the 10 is I squared times I to the 8. I to the 8 is 1. I squared is -1, so this is -1. This is I cubed times I to the 8. -I times 1, -I.
But how do you know when to write 1 or I?
Okay, I'm going to show you right now. Because if it's like I to the 751, we're not going to do this. So there has to be another pattern. So this one is I to the 4. Okay, so this one is I to the 4 times I to the 8. Okay? Which is just 1 times 1 is 1. So do you see how after every 4 it repeats? Right? And then look, you have a 4. And then it repeats, so you have 1, 2, 3, and then once you get to the 4, it repeats 1, 2, 3, 4. So we can use that pattern to our advantage. Since it repeats after every 4 and it cycles through the same thing every single time, we can just go with dividing by 4 and taking the remainder. So here's what you do. When you have I to the 53, nobody has time for this. So we take the 53 and you have to divide it by 4. But you don't divide it like that by 4. You divide it like middle school style with long division. Because you really need the remainder. So we're not going to do we're not going to do it step by step. 4 goes into 53, basically 13 whole times. You can do that on your calculator. It'll give you like 13 point something.
13 remainder 1.
Right. So 13 times 4 is how much? So it's a remainder of 1. Okay? That's all you take. You throw away everything else. Yeah. So this is I to the 52 times I to the 1. And then you ignore the I to the 52. So it's I to the 1, which is I. You just take this part.
So why do you even have to write it?
Huh? Well, you can't write, well, I don't know. You don't have to write it actually. Okay, so Take a look at this one. Yeah, so take a look at this one. 115 divided by 4. Let's just do this. 4 goes into 11 twice. 8. It's always 4 because it repeats every 4. So here we're going to have 35. 4 goes into 35 8 times. Remainder of 3. So this is I to the 112 times I to the 3, really. But you only take the I cubed. And I cubed is negative I. Okay? I to the 74.
Do we have to memorize all this chart?
No, don't memorize. This is why we're showing you this. Don't memorize. You only have to know I to the 1, 2, 3, 4. And even that you could do it in your head. So watch. 1. This is 8. So remainder of 2. So this is I to the 72 times I squared. Just take the I squared. What's I squared? Negative 1. You have to know that by heart. So this is negative 1. Huh? You have to know I squared is negative 1. Everything else, you can just do it. Like, because it's I squared times I is just negative 1 times I. Okay? All right. Now, let's do some more, like, practical examples. All right, so take a look at this. Simplify. 3i times 4i. So basically, you multiply these like you do with any other variable, right? So here, 3 times 4 is 12. I squared, right? Just like if I was any other variable, 12i squared. This will be negative 12. Okay? Here. Okay, there are lots of ways to do this, but we're going to do it. Okay, so here's how you're going to do this. Let me do this whole thing before I take questions about, can you do it this way, can you do it that way? Let's simplify the root first. Okay, the square root of negative 12. So if it was 12, it would be 2 root 3. This is going to be 2i root 3 times. How much is this? The 2 can't come out, but an I can come out. I root 2. So now, you can multiply the stuff on the outside and you get 2i squared root 6. What's I squared? So this is negative 2 root 6. Okay. If you multiply these out first, right? You get root 24, which will give you 2 root 6. Do you see how you lose the negative? The reason is by multiplying them out to each other, you're undoing the fact that these by nature are imaginary numbers. So you're changing the problem and you're making the numbers from imaginary to real. So you cannot do that. You have to take them as they are. Okay, you have to simplify them as they are. Okay? Yeah.
What if in under one root it's negative 12 times the root 2? Like it's not two separate.
Then it's fine. If it's given to you like that, then it's you can multiply them. Okay. Square root property. If you have x squared equal to something squared, you can take a square root of both sides, and then you get x equals plus or minus the number, right? We know this. You've been doing this forever. So this is called the square root property, the fact that you can square both sides, but then the value that you get is an absolute value. So you have to, it's plus or minus. So let's do this. Look at this. It says solve by factoring or by the square root property. So here, let's do square root property. Let's divide by 4. X squared is negative 25. Take a square root. So x is plus or minus what? 5i. Okay? This one, let's do it by the same property. So 5x squared is equal to negative 20. X squared is equal to negative 4. Take a square root. X is plus or minus what? Correct. Now, what is a complex number? Earlier in the lesson, I told you that these numbers here were purely imaginary numbers, right? It's just a constant times an I. Okay. When you have that in conjunction with a real number, right? We can say that that's a complex number. So a complex number can be written as A plus BI, where A is the real part and BI is the imaginary part. Okay? All right. So let's do that here. Let's simplify. Again, it's like adding common terms, right? So this is going to be 3 plus 4, 7 plus 2i. Okay? We always write it as real plus or minus the imaginary. Real first, then imaginary. It's convention. Okay, here, let's distribute, right? So it's 6 minus 5i minus 3 plus 2i. So 3 minus 3i. Don't factor the 3 out. Just leave it that way. Okay? All right, here, we're going to distribute. So I'm going to get 6i minus 15i squared, but I squared is negative 1, so that becomes 6i plus 15. Okay? And then you can write it as 15 plus 6i. So I won't take points off if you're the real I, like the real part first or the imaginary part first, but just know that the book is always going to have the real part first. It's convention. Huh? Because I squared is negative 1? Yeah, I know. Okay. Here, same as always, first, outer, inner, last. So 15 minus 3i minus 6i. Okay, be careful about this part. It's negative, negative, positive 2i squared, which will then become negative. So 15 minus 9i minus 2, 13 minus 9i. How is that so far? Not too bad yet, right? Yeah, Ben.
Minus, is that 15 minus 3i?
Why would it be minus 3?
Yeah.
Wasn't it minus 5i?
Yeah, isn't it minus
Oh no, is it minus 5i?
Yeah.
It's minus
Yeah.
11.
Oh, it's minus 5i. So that would be minus 11i. And here? Okay. Yep. Okay. I take time, like I actually take the time to solve these beforehand, and then I don't look at my solutions even though they're right here. Okay. All right. So we know how to multiply. Let's talk about how to divide. And then I'm gonna, okay. Dividing complex numbers is another situation. Okay. Okay. You know how we never leave roots in the denominator? You also cannot leave any i's in the denominator. Okay? So you have to get rid of the i's in the denominator. The way in which we do that, we have to multiply by what we call the complex conjugate. What is a complex conjugate? If you have a plus bi, the complex conjugate is a minus bi. Basically, what you have to do is you have to change the sign of the imaginary part. Okay, so if I have 2i, what would be the complex conjugate of it? Negative 2i. Okay, if I have negative 5i, what would be the complex conjugate? 5i. If I have 1 minus I, what would it be? 1 plus I. You see the, right?
Be negative one.
No, just the imaginary
Oh,
part.
so not, okay.
Not both, just the imaginary. Okay, so to simplify these, to get rid of the I in the denominator, you have to multiply by the complex conjugate. Okay? So what would we do here? Yeah. So negative 2i on top, and then what do we got on the bottom?
1.
Right, so it's negative I squared, which is negative 1, so it's positive 1. So it's negative 2i over 1, negative 2i. Okay? Okay. Here, multiply top and bottom by 2 plus I. Okay. So, in the numerator, I get what? Okay. Now take a look. This is super important. In the denominator, I have 2 minus I, 2 plus I. A minus B, A plus B. When you've got the same thing with different signs in between, there's a shortcut to multiplying them, right? It's going to be the first one squared, the second one squared, with a minus in the middle. Okay? You guys remember this? Okay. But now this is going to be 6 plus 3i over, how much is that? 4.
5.
4 plus 1, 5. Yes? Okay. But this is all a mess of real and imaginary. We got to split it up. When you split it up, it's got to be 6 over 5 plus 3 over 5i. Okay. It's usually written like this instead of like 3i over 5. Okay, because we do like number imaginary. I is always separate. Okay? Now, we're going to do that a little bit more quickly for the next one. So here I'm going to multiply by 3 minus 5i. 3 minus 5i. Numerator gives me negative 6i plus 10i squared. Okay, denominator. Take a look. Remember how I said square the first one? Yes, that's still the same. Remember how I said square the second one? But before you square the second one, look at what's going to happen. It's always going to end up being a real number. So only if it's i's like this, complex conjugates. Ignore the I when it's a plus b, a minus b. Just square the 5, the coefficient, 25. But then you're going to add them, not subtract them. So it's a little bit different. But you use the shortcut. Okay? Okay. Because it would have been 9 minus 25i squared. Then it would have been 9 plus 25. So that's the shortcut. Only if it's i's to do it that way. No. Well, the top you can, do it in your head? You can, yeah. So this, yes. So this is going to be negative 6i minus 10.
Wait, how do you know when to put a plus?
If it's a plus b, a minus b, if it's complex conjugate. So look here, you have 3 minus 5i, 3 plus 5i. Only then.
But up there, it's
Up there too, we could have done the same thing. Square the 2, you get 4. Square the coefficient, 1. Add them, you get 5.
but then you put a minus sign in between for that one.
Right. So I squared the I, and so I did it the long way. But then I said there is a shortcut when we're dealing with the i's to just square the coefficient and add. If you're still not seeing it, just keep on doing it the way we did here. You'll eventually come to the right answer. Okay? So, wait. So let's see what we've got here. We had negative 6i minus 10 over 29. But now we got to No, over 34. Okay? But now we have to write the real part first, right? So it's negative 10 over 34 minus 6i over 34.
Wouldn't it be 6 over 3?
And then, right, we still have to simplify this one. So negative 5 over 17 minus, minus 3 over 17. Ugh, there's a lag. I. Okay?
Does it matter if the I is greater?
It's usually written like this. I would rather you get used to writing it like this. Okay. Yeah. Okay. Now, here, multiply by 1 plus I, multiply by 1 plus I. So, let's do denominator first. Square the first one, you get 1. Square the coefficient, you get how much? You get, right, you get 1 again, and then you add them. Or if you get minus I squared, it'll still be positive 1. Okay? Multiply the top, 2 plus 2i plus I squared. So this is, that's going to give you 3i. And then what are these going to give you? Okay, so let's just do the whole thing. 2 plus 3i minus 1 over 2. 1 plus 3i over 2. A half plus 3 over 2i. Cool? Okay. We're going to do some more practice with this now. Okay. All right, equality of complex expressions. If you have two complex numbers equal to each other, basically that means the real parts can be set equal to each other, and the imaginary parts can be set equal to each other. Okay? So, look at all this mess. It says find the values of x and y that makes this true. Okay, first you got to simplify this, then you got to simplify that. Okay, you really have to sit up, up. We're lounging you to sit up. Like, okay, everybody else sitting up? Cool, thank you. Okay, so 5x plus 1. Okay, so take a look at what we have here. Do you see how this one, you can see that there is a real part and then there is an imaginary part? What's the real part in that blue? 5x plus 1 is the real part. So you can say 5x plus 1 is equal to, what's the real part in the other side? 2x minus 2. Okay? So, and then what about the imaginary parts? 3 plus 2y is equal to y minus 6. And now you can solve this for x and y. So,
The eyes don't really matter.
no. Yeah. Yeah. So, 3x equals negative 3. X is negative 1. Y equals negative 9. Okay? All right. So,
You can write it. What are the eyes for?
the I, it's just there to say that you have a real part and an imaginary part. The coefficient of the I is the imaginary number part, and you set that equal to the coefficient of the I over there. Okay, let's do some examples here, guys. Just quickly. Okay, where can I? Huh? That's it. X is that and Y is that. That's it. Yeah, I know. That's all. Okay, so take a look here for a minute. We're gonna do some more practice with this, some additional practice. So if I have